So I was saying I will share the syllabus with you tomorrow during the lecture. Today we will directly start with matrices. This is your unit 2 syllabus. So this content we are going to cover in this unit. See, lab માં આપણે શું કરશું? We will do practice. જે lecture માં હું શીખવાડીશ એની practice આપણે lab માં કરશું. But as this is first lab and I didn't take any lecture in your class, we are starting with this new topic, types of matrices. Matrix is a singular word, matrices is the plural word. Now what is matrices? Matrices means plural of matrix. You can go through this definition and the example. A matrix is a rectangular arrangement of numbers in rows and columns. So what Shruti and Jean had said, it is combined in this line. A matrix is a rectangular arrangement of numbers in rows and columns. Rows run horizontally and columns run vertically. I hope you know horizontal and vertical means what. I will draw some matrices here so it becomes easy for you to understand. Okay, so one example is already mentioned over here. I'm giving another example now. You already learned matrices in school. So now you will answer if this is correct example or not. Okay, tell me, is this matrix or not? See, whenever I ask you in group, you will answer in chat box. Write your answer in chat box. Is this a matrix? Yes or no? Write your answer in chat box. Okay, you all are saying it is. Now tell me, is this a matrix? Is this a matrix? Write your answer. Yes, very good. This is another matrix. So all these are matrices. Okay. Now, how many rows are there in this matrix? There are
3.
Yes, 1, 2, and 3 rows. And how many columns are here? 1, 2, 3. So the order of this matrix is 3 by 3. That means there are 3 rows and 3 columns. Now, same way, if I want to write order for this matrix, how should I write? How many rows are here? How many rows?
2.
2. And how many columns are there?
3.
So this is 2 by 3 matrix. Same way here we have rows means which run horizontally. These are rows. So 2 rows, 3 columns. What is order of this matrix? How many rows are there?
3.
Yes, there are
3.
3. Yes. So 3. Shubham, how many columns are there? Shubham?
1.
1. So the order of this matrix is 3 by 1. Now we will go to the next slide. You don't need to write down this. I will share the PPT with you all. but you should have one, particularly one specific to MAVC, one fair book, where you will solve all your assignments. So whenever I will ask for the submission, you will submit the soft copy of that book. So you should have one book for MAVC subject. So this is the thing which I just mentioned about the order. Now, can anyone guess what can be equal matrices?
Which has equal number of rows and columns?
Okay, so now my next question is, okay, let me draw two matrices here. Equal number of rows and columns, fine. So 1, 2, 3, 4, 5, 9. Equal number of rows and columns. These are 2 by 3. And now if I write another matrix with order 2 by 3. Are these equal matrices? Are these equal matrices?
No, ma'am.
They are not. Pratham, can you try? Equal matrices means what?
Yes, ma'am. Where row and columns both are same.
Both
Like three rows and 3 columns.
Okay, so if there are 3 rows and 3 columns, then that becomes one matrix. Okay, I want to know what is this equal matrices. Okay, let me now share what is it. First, let me erase this. Okay, now refer this definition. So your answer was different, was incomplete answer. The last part was missing. Two matrices are considered equal if they have the same number of rows and columns, and all their corresponding elements are exactly the same. For example, now I'm giving you the example. These two matrices are equal if they have equal number of rows and equal number of columns, and all the corresponding elements are exactly the same. These two are called equal. Okay, exactly the same. Now I'm going to the next slide. See, these are the different matrices you will learn in this unit. So today we are going to see what is square matrix, what is diagonal matrix, scalar matrix, identity matrix, all these matrices. So total there are more than 17 matrices, different type of matrices, but we have to learn these 17 matrices. So one by one we will see all these matrices, and to learn these last matrices starting from 11th to 17th. So for these matrices you need to know some other concepts, so that also we will cover. Have you heard these words? How many of these matrices are known to you? Look at these names and write how many are known to you. I'm sure you know some of these, but I want to know exactly how many of these matrices are familiar. Give me the number in chat box. I'm waiting for your answer, students. Okay, so you know 7 to 8 of these. That's great. What is square matrix? Who will tell me? You just have to try. Don't worry about your answer. Square
N
matrix.
cross N,
Yes,
N cross N.
yes, very good. So it is clear from its name. It's a square matrix. Square matrix क्या है? If the size is number of rows and number of columns are equal. N cross N matrix. This is general format, and this is the example. Here we have 2 rows and 2 columns, so it is a square matrix. If you write 3 rows and 3 columns, it is also a square matrix. If you write 4 rows and 4 columns, it is also a square matrix. So in short, number of rows and number of columns must be equal in order to have any square matrix. You can stop me if you have any query. You can stop me anytime. Okay. Now the next is diagonal matrix. આ બધું તમે ભણેલા છો પણ નામથી કદાચ ફેમિલિયર ના હો પણ અત્યારે બધું રિકોલ થતું જશે. Diagonal matrix means it is a square matrix that has values on the diagonal. Diagonal means what? This is called diagonal. This is called diagonal. Okay. A diagonal matrix is a square matrix that has values on the diagonal with all off-diagonal entities being 0. Only you have elements, non-zero elements in the diagonal, and rest all elements are 0. You can see all these diagonal elements are non-zero elements, rest entries being 0. This is the example. This is 4 by 4 diagonal matrix. Chalo, I want another example from one of you. Give me 3 by 3 diagonal matrix. Write the example here.
Ma'am, may I?
Yes,
Excuse me, ma'am.
yes, tell me.
100.
You can write it here on the screen. Let me check if I have given the right format. You can write on the screen. Yes. Great. Chalo, this is correct. All the diagonal entries being 1 and rest entries 0. Now, one of you will give me the example of 2 by 2 diagonal matrix. 2 by 2 diagonal matrix. Who will give?
Yes, ma'am, may I?
Yes. Please go ahead.
Ma'am, I can't able to write.
Okay, then you tell me your first row. First row elements. Give me your elements. I will write it here. Kaushal,
1 0.
1 0. Okay. 1 0.
0 1.
0 1. So diagonal elements trees are there. Rest entries are 0. So fine. This is also diagonal matrix. There is another name for this matrix. And this, which Shruti gave. આ બંને માટે એક બીજું બી નામ છે. What is that? Can you recall that name? Any one of you? Can you recall that name? It's fine if you can give me answer in Gujarati. That term is also valid. Or write in chat
Ekam.
box. Huh?
Vikarna.
એકમ શ્રેણી.
Yes, very good. Fine. ચલો આ બંને એક્ઝામ્પલ થી અલગ પડે એવું example. Brijesh, you give me one example of 2 by 2 diagonal matrix. First row, Brijesh.
Yes, ma'am. -2 0 and 0 to 4.
-2 0 0
0 to 4.
4. Okay, very good. I wanted this example because એવું ના સમજતા કે all these entries have to be same or have to be one. It's not like that. Okay, the entries can be any number. What you have to make sure is non-diagonal entries must be 0. These entries can be any number, any real number, any complex number. The rest of the diagonal, all the entries are 0. That is called a diagonal matrix. Okay. Now I want one example. I will give you the order. I want 3 by 2. 3 by 2 order diagonal matrix. 3 by 2 order diagonal matrix. Who will give me? 3 by 2 diagonal matrix. Akshit, can you try 3 by 2 diagonal matrix?
Yes, ma'am.
Yes, 3 by 2 diagonal matrix. Give me.
7
7
0
0
with one word.
huh?
3 by
Loudly.
0 7.
0 7. This is 2 by 2. I want a 3 by 2.
And that's what I am saying. It won't work. 3 by
So I want one more row here. I want one more row. What should I write here? Come on.
0 0
0
0
0 0. Okay. Are you sure you want to make any change here?
No.
Anybody else?
Ma'am, diagonal matrix is always square matrix. The order has to be same.
Yeah, see, this is the
That's
key
what
word.
I was trying to say.
So
It won't work.
you had to tell me that it is not possible. 2 by 3 matrix is cannot be a diagonal matrix. Diagonal matrix is a square matrix. So that is the first condition. All right, it has to be a square matrix, and then the next part comes that all diagonals entries can be non-zero and off diagonal entries have to be 0. Clear? Scalar matrix means what? It is one type of diagonal matrix, but there these diagonal entries are always equal. Let me first remove this. I'm not able to remove this. Shruti, can you remove this?
Ma'am, I'm trying, but it's not going.
Wonder why. Okay, no problem. I will stop my screen and I will reshare. Okay. So scalar matrix is one type of diagonal matrix only. Diagonal માં આપણે શું હતું કે all non-diagonal entries are zero, rest entries are numbers. But here, scalar matrix means it is a diagonal matrix where these diagonal elements are equal. All these entries have to be equal. You cannot take the different numbers. Okay. So this is scalar matrix. This is a scalar matrix. I want one more from Dhairya. Dhairya, give me one example of a scalar matrix. Order 4 by 4. Quickly. Dhairya,
Yes, yes, ma'am. 1 0 0 0
1 0 0 0
0 1
0 1
0 0
0 0
0 0
hmm,
1 0
hmm.
0 0 0 1.
Very good. This is scalar matrix because all the off diagonal entries are zero and all diagonal entries are equal. Now, Dhairya, my question is, if I write it -1 instead of 1, is it still the scalar matrix?
Yes, ma'am.
Yes, because all the diagonal entries are still same. Okay, so it can be any number in the diagonal line. So this is a scalar matrix. But if it is 1, okay, now there is another name for this matrix. What is that? Which matrix is this?
Adis.
It is identity matrix. That is identity matrix, our next part. The identity matrix I is a diagonal matrix where the diagonal elements are equal to 1. Can you give me another form of the definition for identity matrix? Whatever is written here, that is right. That the identity matrix means a diagonal matrix where all the diagonal elements are equal to 1. Can you give me another way to write this definition or to explain this identity matrix? These are the things which you have already learned in your school. So you should be able to answer this. આપણે start જ એવી રીતે કર્યું છે. We will go from known to unknown. જે તમને ખબર છે ત્યાંથી start કરીને નથી ખબર ત્યાં સુધી જવું છે. So this is a bridge for you all. You must be able to answer it. Anyone?
સર બધા એલિમેન્ટ હેલો મેમ
Yes.
બધા એલિમેન્ટ 1 હોય અને સ્ક્વેર મેટ્રિક્સ થતું હોય.
બધા element 1 હોય square matrix થતા હોય. That's right. That is what written over here.
અને અને ડાયગોનલ મેટ્રિક્સ ની જેમ એકમ એકમ સદિશ એકમ.
Yes, that's also right. Pratham, you tell me.
Yes, madam. If we solve this matrix, we will get answer 1.
Answer means what? Answer means
Means,
what?
madam, we will solve this that like only 1 will come na
How will you
answer.
solve? Solve means, see, solve means what? If there is any question, then you will solve. What is your question? Solving the matrix means what? How do we solve that? Matrix means it is the information. Okay? It is the information. It is not the question. This matrix is showing some information. It is not the question. If it is a question, then you have to solve it. This is not a question. Now, if you want to solve this matrix means what? Solving this matrix is what? Solve કરશો એટલે answer 1 આવશે. That was your statement. Acha, you tell me how you want to solve it. Solve કરશો એટલે શું કરશો? Tell me. Don't hesitate. Please share whatever comes in your mind.
Madam, if we solve this, d is equal to 1.
D, acha, you are saying determinant. You are
Yes,
saying,
madam.
do you know how to find determinant? You know how to find determinant? Okay, leave it. I will tell you how to find the determinant. Okay, but that is finding the determinant. It is not solving the matrix. Okay, see, I wanted to hear a change over here. This is a hint I am giving you. Which other word I can put instead of diagonal matrix? So identity matrix is a diagonal matrix where all the diagonal elements are equal to 1. Instead of diagonal, what other word I can put? In place of diagonal, what is the other possible word which I can put there? Charmy,
All values are 0 except diagonal values.
that is the definition of diagonal matrix. In matrix definition પાછળ નથી મૂકવાની. I just want that one word which I can put in place of diagonal. Yes, Pratham.
Square matrix.
Okay, so now you are saying the identity matrix is a square matrix where all the diagonal elements are equal to 1. Is that right?
Yes.
પ્રથમ તે તો આ કીધું છે એમને બીજા લોકોને પૂછું છું જે પ્રથમ કે છે.
Yes, ma'am.
Okay, હવે હું અહીં એક્ઝામ્પલ આપું છું જે પ્રથમ કે છે એના પરથી. Okay, he said the identity matrix is a square matrix. Okay, so let me draw 3 by 3 matrix, square matrix. So 3 by 3 matrix, so 1 2 3 1 2 3 1 2 3. સરખું ધ્યાન આપજો બધા. Now he is saying a square matrix where the diagonal elements are equal to 1. So I'm putting 1 1 1 in diagonal line. He is not saying anything about the rest non-diagonal elements. So let me write some numbers randomly. Okay, so this is what Pratham had said. Now, is this identity matrix? I'm asking
No,
you.
ma'am.
It is not.
No,
See,
ma'am.
he said it has to be a square matrix. This is a square matrix. And he said all the diagonals should be 1. So here I have put 1. He didn't mention anything about the non-diagonal entries. So I can put any number. But that is not identity matrix. Chalo. I want the word which I can put in place of diagonal.
Ma'am, unit.
Unit means identity. Identity matrix means unit matrix. Similar words. I want replacement at this place. Chalo, think about it.
Ma'am, can we use square diagonal?
Square diagonal. Okay. Who said this? કોણે જવાબ આપ્યો? આ જવાબ કોણે આપ્યો? Square diagonal.
મેમ પ્રથમે.
પ્રથમ કેમ બોલતો નથી? હું પૂછું છું કોણે જવાબ આપ્યો તો? Okay, now Pratham is saying square diagonal. He is saying square diagonal. આના જેવું થયું. હું એમ કહું કે MAVC નો લેક્ચર છે. That's enough. I do not need to say it is maths MAVC lecture. Let me explain. See, when you are saying it is a square diagonal, when it is just you are mentioning diagonal, diagonal આવે એટલે એમાં જ square આવી ગયું ને. What is diagonal matrix? Every diagonal matrix is a square matrix. So when I am writing this word, this comes automatically by default. Are you getting my point, students? Every diagonal
Yes.
matrix is a square matrix. I'll go back to the previous slide. See, what is the definition? A diagonal matrix is a square matrix. હવે diagonal આપણે લખતા હોય તો square matrix એવું સાથે લખવાની જરૂર નથી. It is not required. Right? Let's see this again. What is scalar matrix? Scalar matrix means a diagonal matrix. All of the diagonal elements are equal is called as scalar matrix. What is identity matrix? It is the diagonal matrix where all the diagonal elements are equal to 1. I want replacement at these place. कोई कही सकते कि मुझ कही दो?
Scalar.
Who said this? Akshit. Very good. I can also write here scalar. Scalar means what? Scalar is also a diagonal matrix. Diagonal matrix means alag-alag numbers chala. Scalar means all these diagonal elements are equal. So identity matrix is a scalar matrix where the diagonal elements are equal to 1. So you can write this definition by replacing diagonal by scalar. Now I'm giving example over here for એકદમ સમજાઈ જાય એટલા માટે આપણે ત્રણેય એક્ઝામ્પલ સાથે કરીએ. ડાયગોનલ, સ્કેલર and identity. Diagonal matrix means, see, all these are square matrices only, always, okay? All these are square matrices. We are taking 3 by 3 example. Now, 1 0 0 0 2 0 0 0 4. Scalar is 2 0 0 0 2 0 0 0 2. સરખું ધ્યાન આપજો. Every time, see, it is my habit. I will start my lab and lecture with questions. So make sure you are able to answer. Now, by these examples, you must be clear with the differentiation between these 3 types of matrices. Diagonal matrix means it is a square matrix where non-diagonal elements are 0. Diagonal elements can be any numbers. Okay. Now, scalar matrix is what? Scalar matrix is a diagonal matrix But here the diagonals have to be equal. Okay, scalar matrix is a diagonal matrix where the diagonal entries have to be equal. Now what is identity matrix? Identity matrix is a scalar matrix. Identity matrix is a scalar matrix, but here the diagonals have to be equal and equal to 1. Here any number is allowed, but all numbers should be equal. Like here, if you write 3, 3, 3, that is also fine. If you write 5, 5, 5, that is also fine. But they have to be equal. Here they have to be equal and equal to 1. And here it can be any number. Just you need to check that non-diagonals are 0. Clear? Should we
Yes,
go?
Yes, ma'am.
Okay, fine. This is obvious that when you have all zeros, it is null matrix. When you have only one row or one column, if it is one row matrix, then it is called row matrix. If it has one column, then it is called column matrix. Now, when you are talking of row matrix, there has to be one row, any number of columns. Here we have 3 columns, 1, 2, 3, but there is only one row. So this is row matrix. Similarly, if there is only one column and any number of rows, it is called column matrix. Now, triangular matrix. There are 2 types of triangular matrices, upper triangular and lower triangular. Now, upper triangular means, see here, you will be able to see this triangle. So it is called upper triangular matrix. Now, how to define it? See, it has to be a square matrix first. A square matrix in which all the elements below the diagonal are 0. This is diagonal line. Below that, all the elements are 0. Is called upper triangular matrix. I want one more example of 2 by 2. Who will give me 2 by 2 upper triangular? Charmi, can you try?
Yes, ma'am. 0, 1,
0, 1.
0, 3. No,
Then
ma'am, 0.
Yeah.
Ma'am,
3
wrong.
cross 2 માં જ હોય.
tell me. Yes, Charmi, tell me. You can correct this.
Ma'am, 1, 1, 0, 3.
1, 1, 0, 3. Any objections, students?
Yes, ma'am.
Yes, tell me, what is your objection?
Ma'am, upper triangle 3 cross 3 માં જ હોય. 3 row અને 3 column.
Brijesh,
Yes, ma'am.
કેમ એવું?
Ma'am, close triangle થાય ને.
Triangle માં જો અહીંયા બતાવું હું તને triangle. It is triangular. Only you have to check that below the diagonal, the elements are 0 and it is a square matrix. So this is upper triangular. Okay. Now similarly,
Yes, ma'am.
yes. Now similarly, lower triangular. So lower triangular માં શું change આવશે, Jill?
Yes, ma'am.
Jill, tell me lower triangular matrix. What will be the change in definition?
0 will be gone upward and 1, 3, 1 will be down.
No, I'm asking you the definition. If I want to write this definition same way as this, what will be the change?
A square matrix in which all elements above the diagonal are 0 and is called lower triangular matrix.
Yes. So instead of below, if you write above, it becomes lower triangular. Here you can see the lower triangular. See, it is forming a lower triangular. So whenever above the diagonal entries are 0, it is lower. Below the diagonal elements are 0, then it becomes upper triangular. Fine. Now submatrix. Refer the definition. It's very easy thing. By deleting any row or column, you can write another matrix. For example, here if I delete first column and third row, 2, 3, 9, 8. So this is my submatrix. Or if I just write the first column, or just the second column, or just the third column, or just first row. So it means delete some rows and columns. You will get the submatrix. Now, see, I told you that knowing the other part of the matrices, you need to learn some other concepts. So now we will see that trace of the matrix means what? When you have a square matrix, in that case only you will be able to find out the trace. It is only for the square matrices. The sum of all the diagonal elements of a square matrix is called the trace of the matrix. So for this matrix, 2 plus 6 plus 3, which is 11. So trace of matrix A is 11. You have to add all the diagonal elements of a square matrix. That will give you the trace. Transpose of the matrix. When you interchange the rows and columns, you will get transpose of the matrix. For example, here first column is 104. In A transpose, the first row becomes 10. Here second column is -1, 2, 3. Here second row is -1, 2, 3. So this is the transpose. Let me give you another example for this. One, 2, 3, 4, 5, 9, 8, 7, 6. Now let's find trace here. What will be the trace here? Jin? Give me the first row.
1, 2, 3.
1.
Are you transpose?
I'm asking for the trace. Sorry. Transpose, not the trace. If okay, now you answer for that also. What will be the trace of it? Trace of the matrix. Yes, 1 plus 5 plus 6. So trace of A is 12. Now you give me transpose.
Transpose. It will be 1, 4, 8.
Yes.
2, 5, 7.
Yes.
3, 9, 6.
So this is the trace. Sorry, transpose.
Transpose.
Yes, very good. Transpose means interchanging rows and columns. That is transpose of the matrix, and you can denote it by A transpose. If your matrix is B, then it is B transpose. Okay. Another symbol for transpose is dash. A dash, A transpose. Both are same. Now there are certain properties. Go through this and let me know if you have any query. What is the first property saying? If you find A transpose, it is A again. જ્યારે તમે A transpose નો transpose ફરીથી કરશો તો તમે પાછો A આવી જશે. That is the first property. See, all these properties are useful for MCQ. Another thing is, the transpose of the sum of the two matrices. If you find addition of two matrices A plus B and A no transpose, A plus B transpose, it is same as A transpose or plus B transpose. Now, if I ask you to prove this by the example, if I ask you to prove this by giving the example, what you can do is you will take two different matrices A and B, okay, and then you will take left hand side as A plus B whole dash and right hand side as A dash plus B dash, and they both should be equal. That's how you can prove it. The last property is AB transpose is equal to B transpose into A transpose. Okay, now my question is, can I also see B transpose into A transpose? Multiplication છે તો એની બદલે હું આમ લખી શકું છું કે નહીં? Tell me, is this right or not? This is A transpose into B transpose. Can I write or not? Can I write this or not?
No, ma'am.
No, I cannot write that
No.
because it is matrix multiplication. A multiply B. બે matrix ને જ્યારે multiply કરો તો reverse matrix multiplication answer is different. Okay, so you cannot. So you cannot write this. So this is not true. All right. Now we see what is determinant of a matrix. This is the notation for determinant of A. જે matrix આપણે લખીએ ને ત્યારે એને rectangle માં લખવાનું હોય, but when you're finding determinant, it is two vertical bars and inside you have the numbers. Now, how to get this? How you can get this? Okay, determinant of matrix. So now I will tell you that. For example, you have 2 by 2 matrix. Well, another thing is determinant is only possible for square matrices. Okay, only square matrices. Determinants we can find only for square matrices. Now, how to find it? Now, suppose you are finding determinant for this 2 by 2, 1, 3 minus 1 by 2, 0. So you will do cross multiplication, then minus again cross multiplication, and then you have to solve. Have you learned this in school? Yes, right?
Yes, yes.
Yes,
yeah,
ma'am.
yeah.
Very good. So this is for 2 by 2. 3 by 3 also you have learned in school. Determinant of 3 by 3 matrix.
Yes, ma'am.
Yes, ma'am.
Very good.
Yes.
If it is 3 by 3, do you remember how to solve?
Yes, ma'am.
Yes, ma'am.
Great.
Yes, ma'am.
So in this case of determinant of 3 by 3 matrix, first element 3, and with that you will remove that first row and first column. અને જે આ તમારી પાસે 4 numbers છે, from there you will take cross multiplication 0 to 11 minus 3 by 4 to 180. So that's the first part. Okay, 3 into 0 into 11 minus multiplication of these two numbers. Then after that, કોઈની યાદ છે? કેવી રીતે કરશું?
Yes, ma'am.
Yes, tell me.
Yes, ma'am.
8 minus
Minus.
Yes.
Minus 8.
-8. Very good. So -8 and then cross multiplication of, delete that second row and second column. For the rest of the numbers, you will find the cross multiplication. And the last part is the last number. So minus that 1/4 into rest numbers cross multiplication. And at the end, you have to just calculate it. So this is how you will find out the determinant. Now I want to know what is determinant of 1, 3. This is my matrix 1, 3, 4, 5. Find out the determinant and write your answer in chat box. What is mod A? Write in chat box. By now, everyone should have completed. Shubham, check your answer. Charmi, check your answer. Rest all are correct. Reverse में नहीं करो. See, 5 ones are 5. That is how you have to go. 5 ones are 5 minus 4 threes are 12. So it is 5 minus 12 is equal to -7. So those who have written +7 is wrong. -7 is the correct answer. Now, another example. Find determinant of this. Pratham, here mod means it is the symbol of determinant. It is not modulus value. Okay, so don't get confused. Mod of A, it can be plus number or minus number. It is the symbol for determinant. It is not for modulus value. Hope it is clear now. Chalo, give me answer for this. Brijesh, you need to check your answer.
Yes, madam. It's clear.
It is 0. Now, any one of you directly gave me 0. Without calculation also, you can directly tell me the answer is 0. How? See, the first row is 1, 2, 3, and the second row is 2, 4, 6. Now, if you have noticed, this is 1, 2s are 2, this is 2, 2s are 4, this is 3, 2s are 6. So, whenever you have multiple, એવું તમને જ્યારે બી મળે ને કે કોઈ રો કે કોઈ કોલમ કોઈ કોન્સ્ટન્ટ થી મલ્ટીપ્લાય કરીને સીધી મૂકેલી હોય બીજી રો કે બીજી કોલમ, so always the answer is 0. So without calculation, you can give the answer for this. It is 0. It is one of the property of determinant. આ બધી properties cover હોવી જોઈએ. Now we will go through this property part. તમને મારી સ્પીડ બરાબર લાગે છે કે થોડું ધીમું કરવાની જરૂર છે? Tell me.
No, ma'am.
નો મેમ.
ઓકે, કેમ કે આ બધું તમે શીખેલા છો તો તમને ક્યારે એવું લાગે તો બી એની ટાઈમ you can stop me. Okay, don't worry. So these are the properties. Determinant of matrix and its transpose are equal. See, if you write matrix A and the transpose of A, and if you find determinant for both, it will be equal. Then if any two adjacent rows or columns of a determinant are interchanged, the value of the determinant changes only in sign. You can verify it by taking one example. You can check it now whether it is true or not. Check કરીને કયો મને એવું થાય છે કે નથી થાતું for the second property. ચેક કરીને કયો મને. આનો મતલબ સમજાવો કે સમજાવું? See, I'll draw it here.
ફર્સ્ટ રો ને સેકન્ડ રો માં જવા દે, સેકન્ડ રો ને ફર્સ્ટ.
હા, yes, એવું તમે કરો તો આન્સરમાં શું થશે? આન્સરમાં ખાલી સાઇન ચેન્જ થશે. ફોર એક્ઝામ્પલ, લેટ અસ ટેક અ સ્મોલ એક્ઝામ્પલ. 1 2 3 4. What is the determinant for this? 4 ones are 4, 4, 3 twos are 6, 4 minus 6 minus 2. Okay, it is minus 2. Now I'm interchanging these rows, so it becomes 3 4 1 2. તો હવે આનો આન્સર શું આવવો જોઈએ? આ -2 હતો તો આનો આન્સર +2 હશે. 3 twos are 6 minus 4 ones are 4, 6 minus 4 2. That's it. All right. Similarly, you can check કે કોલમ ને આમથી આમ કરી નાખીએ તો પણ એ જ થશે. Every of this property you can verify by writing an example. If any two rows or two columns of a determinant are identical, identical means they are same, or they are multiple of each other, then the value of the determinant is 0. આ એ છે જે હમણાં આપણે વાત થઈ, જે હમણાં મેં તમને એક્ઝામ્પલ આપ્યું હતું. Okay, it was example for this second part. Multiple of each other. હવે હું તમને આનો એક્ઝામ્પલ આપું. If they are identical, suppose your matrix is 1 2 3 1 2 3 4 3 minus 1. Now if you find determinant for this, it will be 0 because these two columns are identical. You can verify it. Last, if all the elements of any row or column of a determinant are 0, then the determinant is 0. If there is entire row is with 0 or entire column is 0, then the determinant becomes 0. That also you can verify. All these properties you can verify. Now, if all the elements of any row of a determinant are multiplied by a quantity k, the value of the determinant is multiplied by the same quantity. That means, see, I will explain by an example. Okay. See, suppose you have, let's say, 2 1 4 3. What is determinant for this? If this is matrix A, then mod A becomes 2 3s are 6 minus 4 1s are 4 is equal to 2. Now I'm multiplying by k. Okay, let me multiply first row with k. K ne હું લઉં છું 2. Okay, the first row becomes 2 2s are 4, 1 2s are 2. rest entries as it is. Now what is determinant for this? 4 6 are 12 minus 8, 12 minus 8 is 4. So answer 4 આવ્યો. આનો શું હતો? 2. Because I multiplied the row with 2, I got 2 into 2, 4. Okay. Now instead of multiplying with 2, if I multiply first row with 3, then answer will be 6. 2 3s are 6. So that's what this property means. So all these properties you can verify by example. Now singular matrix. Now if determinant is 0, it is singular matrix. Give me one example of singular matrix. Who will give me example? Give me one example for a singular matrix. Who will give me example for singular matrix? Andrew. Sorry if I pronounced your name incorrectly. How do you pronounce your name? Andrew? How do you pronounce your name? Are you here? Unmute yourself. Roll number 23. Roll number 23.
Yes.
What did I ask you?
Pardon?
What did I ask you?
I didn't get you well.
Where were you? Pay attention here. Okay, now Kelvi, you give me example for singular matrix.
Yes, ma'am.
Yes, give me example.
1 0 0 0 1 0 0 1 0.
Kelvi, why this is singular matrix?
Yes, ma'am.
Why are you saying this is singular matrix? Kelvi, a singular matrix કઈ રીતે છે? Explain that. Come on, tell me.
No, ma'am. Nothing.
કેમ નથી?
But ma'am,
Yes, what?
ma'am થાશે કેમ કે આન્સર આપણે 0 લેવાનો છે તો
Answer એટલે?
determination of A.
What is determinant of this matrix?
બધા 1 લેવાનો.
What is mod A?
May I answer, ma'am?
No. Let her. Kelvi, what is mod A?
0.
0. Since mod A is 0, it is singular matrix. It was very simple.
તો મેમ
Because-
અહીંયા આમાં બી થઈ શકે ને.
So your answer was correct. You are not confident. You gave me correct example. You couldn't explain why it is singular. It is singular because determinant is 0.
0.
So when determinant is 0, the matrix is called singular. Otherwise, it is called non-singular matrix. The next is symmetric matrix. Symmetric matrix means first row is same as first column, second row is same as second column, third row is same as third column. It is called symmetric matrix. Mathematically, we will say if Aij is equal to Aji. Aij means what? I is number of row and J is number of column. So for example, I write A34. That means third row, fourth column. So element in third row, fourth column should be same as element in fourth row, third column. So mathematically એવું કહે છે કે ith row jth column નો જે element હોય એ જ element jth row અને ith column માં હોવો જોઈએ. For example, here you see this is first row, first column. First row, first column. This is first row, second column. So it is called A12. This is A12. So A12 is equal to 4. So A21 also 4 होना चाहिए. Second row, first column. This is second row, first column. 4. It is 4. Okay. So if Aij is equal to Aji, then it is symmetric matrix. And this is keyword. It has to be a square matrix. Okay. A square matrix is called a symmetric matrix if Aij is equal to Aji. Now I want a 3x3 symmetric matrix Kashyap. 3x3 symmetric matrix Kashyap.
0 0 0
0 0 0
0 1 1 1 0 0.
Are you sure? See, અહીંયા છે.
ઉપર સર
હા?
હા ત્યાં 1 કરું.
ક્યાં?
1 કરવું પડશે.
ક્યાં?
પહેલી રો માં ત્રીજા નંબર ઉપર
અહીંયા.
અહીંયા. હા.
Okay. So first row is 0 0 1. First column is 0 0 1. Second row is 0 1 1. Second column 0 1 1.
0 1 1.
Okay. Third row 1 1 0. Third column 1 1 0. So now it is symmetric matrix. I want one more example. Kausha, give me example. Symmetric matrix. Pratham, you gave me as you have raised your hand. Give me
Ma'am,
one.
please explain this symmetric matrix again.
Okay.
I
Okay.
didn't.
Yes, fine. See, agar first row is 1 2 3, then first column should be 1 2 3. If second row is 2 1 4, then second column should be 2 1 4. If third row is 3 4 9, then third column is also 3 4 9. Did you get it now?
Yes, ma'am.
Let's take 2 by 2 matrix. If it is 1 9, first row, the first column also should be 1 9. Now second row is 9 2. Second column also 9 2. Understood?
Yes, ma'am.
But see, we will have to write it mathematically. So how we are writing it mathematically? Okay. If Aij is equal to Aji, now what does this mean? Ith row, the J number ni column no element je hoy, the same element should be in jth number row and ith number column. Like for example, second row, third column element must be same as third row, second column. For example, in this second row and third column, it means this 4. So third row, second column. Third row એટલે આ, second column છે આ. તો આ કયો element થયો? આ પણ 4 જ છે. Okay? So Aij
Yes, ma'am.
should be equal to Aji. So it is called symmetric matrix. Clear?
Yes, ma'am. Clear.
Okay. If it is clear, give me 4 by 4 symmetric matrix.
1 0 9. 4 by 4 na madam?
Hmm.
4.
Hmm.
0. Um,
ફર્સ્ટ રો લખી નાખી તો ફર્સ્ટ કોલમ લખાવી દે.
તો 1094.
Now second row. Any number.
0, 0, 8, 7, 6, 7 and 6.
Hmm.
5, 3 and 3, 2.
Perfect. Clear? Second row exactly should be same as second column. Fourth row should be same as fourth column. Nth number row should be same as nth number column. That's symmetric matrix. Is this clear, students?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
આ ક્લિયર હોય તો જ આપણે આગળ જાય. ઓવરડોઝ નથી થતો ને?
No, ma'am.
Okay, that's great. Now, skew symmetric matrix. Symmetric માં કેવું હતું કે first row same as first column. Skew symmetric means first row is same as first column but the sign is different. Okay? જેમ કે અહીંયા છે 0, -3, -4. Sorry. First column is 0, -3, -4. First row is 0, -3, -4. So first column should be 0, 3, 4. Same numbers હોવા જોઈએ but sign અલગ હોવી જોઈએ. Okay? Is that fine? Clear? Any query?
Yes, ma'am.
Now give me one example for 4 by 4 skew symmetric matrix. 4 by 4 skew symmetric matrix. Who will give? Chalo, I will. Let me ask Shubham ke Parth. Chalo, Parth guess. Parth, give me first row.
Yes, ma'am. Wait, ma'am. 3 cross 3 or 4?
Huh?
3 cross 3 क्या 4 cross 4?
4 cross 4.
4 cross 4. Wait. 0, 2, 3,
0, 2, 3,
4.
4.
Column was 2, 3, 4. 0.
કયો મેટ્રિક્સ આ વસ્તુ?
Skew matrix, symmetric.
Asymmetric થાય.
એટલે -2, -3, -4.
Yes. Now
0, -1, -2, column second 1, 2, 0, 5, -5, 0.
very good. Here you can see it is same as what we have mentioned earlier. Now Shubham will give me one example of skew symmetric for 3 by 3. Shubham.
Yes, ma'am. 0, 1, 5, -1, -5, 0, -4, +4 0.
Very good. Now my question is, why every time you are giving me zeros in diagonals? Who will tell me? મને એના સિવાયનું કોઈક એક્ઝામ્પલ આપો. મને ડાયગોનલમાં ઝીરો નથી જોતા. ચલો, શ્રુતિ, you can try. I want to start with 1. Make it 3 by 3 skew symmetric. Shruti.
Yes, ma'am. 1, 5, 7.
5, 7.
Column 5, 7.
I want skew symmetric.
Okay.
Shruti.
Yes, ma'am. I'm doing a minute. -5.
Yes.
-7.
Okay. Any objection, students here?
Yes, ma'am. Yes, ma'am.
Yes.
મેમ તમે એમ કીધું કે aij equal to -aji એમાં મેમ ai નું aj નું તો તમે કઈ કીધું જ નહીં એટલે એમાં aii એ
Should be same as minus aii. It is for every element. It is for every element.
મેમ aii એટલે સેમ a11 a22 ને a33 equal to 0 જ હોવા જોઈએ.
Yes.
Geometric.
Why so? Because જો હવે અહીંયા શું પ્રોબ્લેમ થાય? 1, 5, 7. That is fine. But first column should be opposite of it. So it should be -1, -5, -7. Now if first column is minus, 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 then first row should be plus, plus, plus. So this is the number. These are the numbers where we see this issue. Are you getting my point, students? So what's the solution? All diagonal entries must be zeros. કેમ કે zero જ એવું છે કે જેનું plus or minus both are equal. I don't need to write +0 or -0. અહીંયા હું 1 લખું તો first row માં 1 હોય તો second column start થવી જોઈએ -1 થી, which is not possible, right? Yes, Pratham.
મેડમ સિમેટ્રિક મેટ્રિક્સ માં પોસિબલ છે ને આપણે ગમે તે યુઝ કરી
So symmetric માં તો કેવું હતું કે એ જ નંબર આપણે રાખવાનો હતો. First row is exactly same as first column. અહીંયા problem છે. શું કામે? Because we wanted to have the opposite sign. હવે એક જ જગ્યાએ એક જ એલિમેન્ટ માં હું પ્લસ બી લખું માઈનસ બી લખું, બે તો ના લખી શકું. સમજાય છે?
યસ મેમ સમજાઈ ગયું.
So I only have one option, that is putting zeros. So in skew symmetric matrix, remember always the diagonal entries are 0. ગોખવાનું નથી. You have to understand why it is 0. ન સમજાણું હોય તો I can repeat it again. You want me to explain again, students?
No madam.
Yes, can you repeat again?
Yeah, who is this? Kaushal. Okay, Kaushal, skew symmetric means what? Tell me, what is skew symmetric, Kaushal?
Ma'am, I can give example, ma'am.
No. Meaning.
It mean, ma'am, I can give the difference between symmetrical and q-symmetrical.
Okay, give me.
Ma'am, in symmetrical, we have take any of the numbers not what I'm saying that.
See, symmetric means first row is same as first column. Second row is same as second column. Okay, but in skew symmetric, first row means opposite of first column. એટલે કે અહીંયા મારી પાસે જો 2 હોય ને તો અહીંયા શું હોવું જોઈએ, કૌશલ? Kaushal, see, these are the positions. Okay,
-2.
Yes, yes, it has to be -2, right? Very good. If I write -3 here, તો અહીંયા મારે શું લખવાનું? 3. Okay. અગર હું અહીંયા લખું 4, તો અહીંયા શું લખીશ?
-4.
Yes. અહીંયા હું લખીશ 1. Okay. ફર્સ્ટ રો માં મેં ફર્સ્ટ એલિમેન્ટ 1 લખ્યો, તો ફર્સ્ટ કોલમ નો ફર્સ્ટ એલિમેન્ટ શું હોવો જોઈએ?
1.
નહીં, ઓપોઝિટ ઓફ 1 ને? સ્ક્યુ સિમેટ્રિક છે. અહીં શું
Okay.
લખું?
Okay. Okay.
અહીંયા જો અહીંયા -1 લખું તો રો જ્યારે હું જોઉં ત્યારે શું હોવું જોઈએ? +1 હોવું જોઈએ. પણ હવે અગર હું રો માં એને +1 લખું છું તો મારે કોલમ માં શું આવવું જોઈએ? -1 આવવું જોઈએ. તો both not possible. No, I cannot write 1 and -1. I can only put 1 entry in this box. So what is the possibility? Only possibility is putting
0.
Understood now?
Yes. Yes, ma'am.
Okay. So in skew symmetric, always the diagonals are 0. The next is conjugate of a matrix. You have to remember all these things. Next time when you will come, I will start my lab with these questions. Okay. Conjugate means, let's not see the formula. Let's see the example, so it will be clear. 1 plus 3i. So when you write conjugate, you have to write 1 minus 3i. 2 plus 5i. So you will write 2 minus 5i. Like a complex number, there you will have to change the sign. Okay. If it is minus I, you will put I. 6, 6, 8, 8. Only the imaginary part you have to change with the sign. Okay. A matrix obtained from any given matrix, on replacing its elements by the corresponding conjugate complex numbers, is called the conjugate of A. And it is denoted by A bar. Okay. Another example. If I say A is equal to I3 minus I, let us take 2I minus 5. Okay. So what is A bar? A bar will be, this is I. So this becomes minus I. 3 is real. So it will remain as it is. Minus I will be I. 2I will be minus 2I. Minus 5 will remain as it is. So only imaginary part you will change the sign. Clear, students? This is how you will write the conjugate. Okay? Stop me if any query. Otherwise, I will go ahead.
Yes, ma'am. Okay.
Transposed conjugate of a matrix. PPT share કરી શેર કરી નાખીશ. This is extra આવી ગયું છે ક્યાંથી, હમણાં હું edit કરી નાખીશ. Okay, so don't look at this and don't look at this. Okay, my mistake લખાઈ ગઈ છે. Now what is transposed conjugate of a matrix? Now નામમાં જ ભૂલ આવી ગયો. Conjugate means what? I just explained. Imaginary part નો એમાં sign change કરવાની. That is conjugate. Now conjugate અને એનું શું કરવાનું છે? Transpose. What is transpose? Interchanging the rows and columns. આ બંને આપણે separate definitions we already learned. I told you what is transpose of a matrix. I told you what is conjugate of a matrix. Now these two things you have to do together. So it becomes transposed conjugate of a matrix. And the symbol for transposed conjugate is A theta. A theta is equal to A bar transpose or A transpose bar. If you first find transpose and then find the conjugate, or you first find the conjugate and then find the transpose, both will give you the same result. Now this is my matrix A. I want A theta for it. So first I have found A transpose. A transpose means all rows interchanged, all rows and columns interchanged. that will give me A transpose. तो જે first row છે એ first column થઈ ગઈ. આ first row હતી એ first column. This was my second row, which is here second column. Third row has become third column. So this is transpose. Now conjugate means imaginary part ni sign change करवानी. So 1 minus 2i becomes 1 plus 2i. 4 minus 5i becomes 4 plus 5i. Okay, so changing the sign. So this is my A theta. Refer this example. Let me know if you have not understood. Is that clear? It's clear, students?
Yes, ma'am.
I will write one small example. Let's take a 2 by 2 matrix. So let me take 3, 4i minus I, 6. Okay, this is my matrix. Now I want A theta for this. This is my A. I want A theta. So first I will find A transpose. There, what will be A transpose for this? First column, શું થશે ધૈર્ય? ધૈર્ય?
Yes, ma'am. Yes, ma'am.
First column.
A transpose. નીચે મેમ 3 છે I minus 6 અને બીજું શું?
3, 4i minus I, 6.
Okay. 3 minus I.
So you're saying column or row?
No, vertically, ma'am. 3 then
Vertical. Okay. So
horizontal one. Sorry.
horizontal.
Sorry.
3 minus I. And here
4 and 6.
4i, 6. So this is A transpose. Very good. So what he has done is interchanged rows and columns. Now I will find A transpose bar. Jill, what will be A transpose bar? That means A theta. Jill.
Yes, ma'am.
Jill.
Yes, ma'am.
Give me A transpose bar. Give me
3.
3.
3 minus 4i.
બેટા ક્યાં ધ્યાન છે તમારું? You are giving me A bar. I want A transpose bar. Jill. ધ્યાન ના હોય ને તો જવું થાય. You are giving me from A. A transpose is found here. Look at this. And from this you are giving me A transpose bar.
Uh, 3 3i
Yes.
plus I. 4 minus 4i. 6.
Yes. Thank you. Pay attention, please. If you are not attentive, you are going to miss so many things. So this is A theta. So this is one way of getting A theta. Like first you find transpose and then you find conjugate. Or other way is you first find conjugate. Like see, for this matrix, I can first find the conjugate. Then it is 3 minus 4i, I and 6. Okay, so this is A bar. And હવે હું એનો ટ્રાન્સપોઝ કરીશ તો બી આ જ આન્સર આવશે. So both the ways will give you the same answer. This મને જે હર્મિશન સ્ક્યુ હર્મિશન નથી કરાવું, તમે confused થઈ જશો. So let's take that in the next class. I don't mind if you want to go ahead. આગળ કરું કે next lab પર રાખું છું? Give me your opinion. Give me your opinion, students.
Next step.
ठीक છે, ચલો. Okay. So next time we will do that. But make sure whatever we have done today, next time when you come, next time when you will come, you will refer my notes and then you will enter the lab. Okay. So that's very important. Every time, whenever you're coming for my lecture or lab, you will refer the notes which I will share with you. Now, can I see you all? Can you all turn on your camera because I want to see you all. આમ તો મળવાનું થવાનું નથી. We don't know. We cannot predict, right? મને એમ લાગે કે હું સામે સ્ટુડન્ટ્સ જ બેઠા છે. હું એકલી નથી બોલતી. I really wish કે જલ્દી તમે બધા કેમ્પસમાં આવો. તો મને ખબર પડે કે સાચે સામે બેઠા છો. જ્યારે મને તમે જવાબ નહીં આપો ને, હું બહુ મને ગુસ્સો આવે ત્યારે બહુ આવે. જવાબ નહીં આપો ને 2 વાર બોલીશ જેલ જેલ, તો જેલ નહીં બોલે ને તો જેલ સીધી ક્લાસની બહાર રિમૂવ કરી નાખીશ. પછી you will not be able to come back. Okay, so make sure you are always there. મોબાઈલમાં ચાલુ રાખીને નીકળી જવાનું ને એવું કાંઈ કોઈ દિવસ મારી સાથે કરતા નહીં. બાકી અઘરી પનિશમેન્ટ મળવાની છે. Okay.
Okay.
And whenever I give you any assignment, I want it to get on time. Canvas પર છો તમે લોકો? Are you familiar? Canvas use કરો છો?
Yes, ma'am.
Okay, Canvas પર હું સબમિશન લઈશ જ્યારે બી લઈશ ત્યારે. Okay. મેં મને introduce કરી નહીં, directly I started. I'm Forum Rajdev and I'm teaching here since last 7 years in this university. And એની પહેલા પણ 6 વર્ષ. So I am teaching mathematics since 12-13 years. And I'm also chairing women's cell of our university. So ક્યારે કઈ complaints હોય તો મારી પાસે આવશે. તમે બધા ડાયલાગો છો એટલે એક કમ્પ્લેન આને બોલાવજો. ચલો હવે આજે જે મેં ભણાવ્યું છે એમાં કઈ ક્વેરી હોય, you can message me. You all have my number. You can message me anytime. કોઈ બી લેક્ચરમાં લેબમાં ના સમજાય, you can write in chat box. And if you're hesitating, you can message me and I will answer you there. Okay, I hope it was clear. Types of matrix is very easy thing and you already learned it in school, but still if there is anything, please message me. Okay, chalo, see you all tomorrow in next class lecture.
Excuse me, ma'am.
Thank you. It's okay, Kaushal, I understand, no problem. Chalo, thank you, goodbye.
Thank you, ma'am.
Thank you. Wait, students, wait. I forgot to take attendance. One due. One gayo. Ek kona number I just said.
So, ma'am,
What is his roll number?
I think Shruti, ma'am. 30.
There were 17 in total. कौन बे निकली गया? एक श्रुति.
शुभम श्रुति.
शुभम and श्रुति. Okay. बाकी नाम હું screenshot ले लूँ. Fine. Done. Thank you. Goodbye. Thank you.
excuse me, ma'am.